Hello, welcome. Let's try to solve another Leetcode problem, 532 K-diff pairs in an array. So we are giving an array nums and we are also giving an integer k, and we need to count how many different pairs, how many K-diff pairs. So the definition is the ij gonna inside the range from 0 to n minus 1, and I not equal to j, and absolute of nums I minus num j gonna equal to k. Yeah. For this example, for the first example, we should know that 3 minus 1, 5 minus 3, so it's gonna have two pairs, so we're gonna return 2. And for the second example, we have 4 pairs, as you can see from here. And for the third example, we only have 1 pair, because it's gonna be 1 and 1. How can we solve this problem easily? So the first idea is that we're gonna use the brute force. So by using the brute force, yeah, we can sort the nums or we cannot, but it is both okay, I think. Let me just prepare some brute force to solve the problem, So we're gonna prepare the length of the nums and weighted set, because we're gonna check how many different pairs, and we're gonna use 2 for loops, and we're gonna check the absolute value. So if it is equal to k, we're gonna put it inside the weighted set. After that, we're gonna check the length of the weighted set. Yeah. So for this problem, the time complexity is gonna be O(n) squared, and n gonna be 10 to the power of 4. This means it's gonna be a really big number. So that is why it's really slow. Yeah, let me just put the nums sort inside, because I think in my algorithm I need to sort the nums. Otherwise, it's gonna have duplicate. Yeah, it's gonna have duplicate like 3, 5, and 5, 3. So that is why I'm gonna sort the nums, because I'm gonna keep it like 3 and 5. Yeah, now let me just submit it again to check it really works. Yeah, so now as you can see it works, but it's nearly 8 seconds, and definitely this is not a good algorithm, because basically this is just the brute force. Yeah. Now we're gonna use the same idea to solve the problem, but we're gonna use the two-sum idea. So this means basically we're gonna use a hash set or hash table to solve the problem. Because if we don't use that, here is currently a weighted set. Basically this is O(n) squared. Now we want to run this algorithm by using just O(n) time. So the two-sum idea is that yeah, so I'm gonna prepare 2 sets. One set is a weighted set, another is just a set. Yeah. I'm gonna enumerate all the nums. So for I will enumerate from the nums. Yeah. I'm gonna set a result, so I don't need to use this n, but I want to set a final result. It's gonna be 0. So currently I want to check if v minus k. Yeah, because currently it is k equal to 2. We want to have 2 values, like b minus a gonna equal to 2. Yeah. So currently we are going to check what gonna be this a. So a gonna equal to b minus 2. So a gonna equal to b minus 2. So we're gonna check if this b minus 2 is inside the set. If it is inside the set, this means we're gonna meet this formula. We're gonna count it as 1. Yeah. So if v minus k inside our set. So currently here I'm gonna use this weighted set. So if it is inside the weighted set, I'm gonna plus equal to 1. And after that, my weighted set, I'm gonna add the previous number, so it's gonna be this way. So finally I'm gonna return the result, but this didn't work. Let me just run it. Yeah, it works for some testing cases, but definitely it didn't work for all testing cases, and we can find why. Yeah, as we can see, it didn't work for this testing case. So the idea is that we sorted the nums and we prepared a weighted set. Yeah. But what happens if there's a duplicate? So for the third example, we have 1 and 1. So what if we have 3 ones? Yeah, so first this one is this one, okay? And then we have another one. It is Yeah, it is still inside the weighted set, but we should not count it because this is a duplicate. How can we avoid that? Yeah, basically we need to avoid that. So the idea is this way. So for this number, it must always be unique numbers. Otherwise, we're gonna have duplicate. So what are we gonna do? So we're gonna have another check. If v not inside the set S, and v minus k not inside the weighted, so what are we gonna do? So this S gonna add this v inside. Yeah. So in this way, we use the two sets, but the time complexity becomes O(n) instead of O(n) squared. Yeah, because if this v is unique, this means all the pairs should be unique. So for example, if we have 1, 1, 1, if we used one, already used this one, so what about the next one? Yeah, because it is inside this set, definitely we will not use it. So we're gonna avoid all those kind of duplicates. So like 1, 1, 1, 1, 1, and k equal to 0. How can we avoid that duplicate? We only used one time of this one. So for the next time, because it is already inside, we don't need to use that. So this is why we're gonna use this kind of idea to solve the problem. Yeah. Now let me just submit it to check. Yeah, as you can see, now it is really fast and it becomes 7 milliseconds, and the time complexity becomes O(n). So I think this is a really good algorithm. This is a really good problem. Although it is similar to two-sum, but this is just another description of two-sum problem. Thank you for watching. See you next time.